to help you appreciate, to understand what p-values are. Okay, is extremely important. It's in our daily life. Let's say your friend saying that he can shoot basketball. Your friend said he can shoot basketball. He can make it 60%. Your friend, okay? And then you say, shoot it. And then he shoot it in front of you. Then he did 20 times, and he made 8. He made it 8. So what's the proportion in this time? What's the proportion? What's the proportion? 40%. 40%. Okay. So can we trust him? He said his average is 60%. And you said, show me. And he this morning, he did it. 20 times, he made 8. He made it 40%. Then he said, oh, this morning, I didn't sleep well yesterday, but believe me, my average rate is 60%. Believe me. They said, oh, I didn't have breakfast. It's too cold. Oh. So, can we, based on this, can we trust, is he lying or is that? So, to get this, we need a p-value. This is the p-value. I will do this. Then after you listen well, then I will change the time. Like now he shoot 20 times. He made 8. Okay. I tell you ahead of time. After I finish this, then it's your turn to do this. Another person, let's say another person, he also said, I can make 60%. And he said, show me. And he tried 10 times. He made 4. He made 4. And it's 40%. Right? This morning, the person B, he made 40%. The person A made 40. Person A, there's a difference, okay? There's a difference. Person A, he did 20 times, and he made it 8. He got 40. Person B, he made it 10 times. Even though both are 40%, the result is very different. And this is your question. This is mine. Okay. So how can we use a p-value to determine if a person A is trustable? You determine if person B is trustable. So what is the standard deviation? That is a golden formula. That's a golden formula. For proportion, for this binary, yes or no, the standard deviation is the standard deviation is this. Okay. And if it is for the average, if it is for the average, a different scenario is I don't know which symbol I use. Is also the standard deviation. Is also standard deviation. That our come to the second scenario. Okay, hopefully today. Hopefully today. But here is the standard deviation for this yes or no. So, to make my story, to rephrase the story in mathematical way is null hypothesis. Hypothesis. In the beginning, we always assuming people are innocent. We assuming he is right. So this is O. It's not 0. Doesn't matter. We assuming that he is 60%. Okay. And later, after the p-value, we found that this is unlikely. This is in very, very small chance he is innocent. Then the alternative hypothesis this A means alternative, is not 60%. He could be too humble. He could be too humble. His true performance is better than 60%. He could be bragging. His true performance is not as good as 60%. The bottom line is if that it's unlikely his performance is 60%. This is one kind of hypothesis. Is two tails. He could be too humble. He's Michael Jordan. Oh, he's too humble. Or he could be bragging too much. He's not as good as 60%. this is so could be worse, could be much better, but it's not. I need to use this, so I erase here. I give it back. So we understand that the life has some randomness. So that's assuming, let me use the decimal, because it takes less space. In the beginning, we're assuming that this is him, okay? And later we find out it is impossible. It is impossible. Is a very, very small chance that this is true. So the standard deviation is this P we take because we assuming this is true, okay? So we use this, not this. It's easy to make mistakes. We use this, not this, okay? So the P is a 0.6, okay? Times 1 minus 0.6 divided by the n. How many? What is n? 20. Your question is not 20, okay? And because it's different, these will be different. And all the results will be changed. All the results will be changed. And the result is 0.109, something like that. For easy to be easy for teaching, I think this example is from your textbook or from. So we just make it as 0.1. Okay. If you don't feel comfortable, I add the symbol. It's a 0.1. This makes our teaching easier to go. You know, I just ignore the 009. Okay? So, standard deviation. So, what's here? This is a 1 standard deviation. So, what's here? 0.7. 0.7. What's here? 0.5. Where is this guy doing? He's a 0.4, okay? He's a 0.4. Okay? Now we keep going, what's here? 0.8. What's here? Oh, this guy is here. 0.4. No need 0. It takes too much space. Okay. This is the likely probability. So person A, color. When I'm looking at the color chart, you know what I'm going to do. So what's the probability of this? What's the probability of this? What's the probability of this? Huh? Well, I'm looking for chart, color chart. You know what I'm going to do. According to the rule 68, 95, 99.7, what's the red one plus the green one? Huh? The red one plus the green one is 5%, right? This one plus this one. Because from point 4 to point 8 is 95%. This is a 1 z value. This is a 2 z value. Okay, this is a negative 1, negative 1 z value, negative 2 z value. Okay. So the black one is a 95%. And the red one plus the green one is a 5%. So the p-value, this plus this is a 5%. So this p-value is 5%. Is not 60%. Is could be worse, or could be he's Michael Jordan. Could be better. This total is the probability. The probability here to tell is a 5%. Is a 5%. So the p-value is 5%. In daily life, if is a 5% chance, that since how to say, since his performance is a 0.4, if this is a him, if we trust him, this is a him, then that is, let me do the one tail of the web. Alternative is his true performance is less than 60%. His true, in the beginning, we're assuming he indeed is a 60%. Alternative, there are two ways. One way is two tails. Means he could be worse, he could be less, or he could be too humble. Another is we just alternative. Say his true performance is less. Let's finish do this p-value first. This is a point. This is what's this? 2.5%. Okay. If this is a him, only 2.5% chance. This morning, what 2.5% chance. So basically, we think this is not him. We think this is not him. We think this is unlikely. We think this is unlikely. So we believe the alternative, his true performance is less than 60%. And the p-value for this one tail is 2.5%. Okay, the 2.5% means there if this is a him, only 2.5% chance to fit this morning's performance. And for two tails test, that we don't care if it's worse or if it's better, but we reach the conclusion. Impossible. It's just impossible to be 60%. I'm not sure he's better than or he's worse, but it is impossible. It's only 5% chance to explain this morning's performance. It's only 5% chance to explain this morning's performance. He could be better, he could be worse, but it's impossible to be 60%. This is a two-tail. And this is a one-tail. We only consider in one way. It's impossible to be 60%. He's bragging. He is bragging. Only 2.5% chance that to explain him. So this is the end of this question. Do you want me to do that second person B? Do you want me to do the person B? Because the person B, the conclusion will be opposite. Then I do the person B, okay? So may I erase this board? Okay. So this morning, the person B, you say, show me, and he shot 10 times, he made a 4, looks like 40%, or this is 0.4, okay? And this much is similar. Initially, okay, you are 60%. And but let's say this morning is only 40%. Let me see by p-value. You are saying, oh, it's too cold. Oh, no. I didn't have breakfast, so and so. So I just made. But trust me, I am a 60% shooter. Okay, now we took here. Okay, assuming this is the truth. Assuming this is the truth. So 0.6, 1 minus 0.6, and here is a 10. Okay. Here is a 10. And this the number is ugly. It's not as nice as that. But this is my purpose. And is 0.1549. 0.1549. And I just as 0.15. Okay. Okay. Now, so the standard deviation is the person A. What's the person A's standard deviation? 0.1. Okay, it's 0.1. Person A. Person B is 0.15. Okay. Then both person A and person B is centered at the 0.6. Okay. Both person A and person B. So how to draw this? So will be factor for person B because the standard deviation will be factor. Okay. Because everything below is 100%. You see it? Everything below is 100%. So if this is a factor, this will be lower. This will be lower. Okay? So it will be, let me try my off. Okay? Will be like that. I should use a different color. Oh, maybe before. Standard deviation is a greater. So for person B, the one standard deviation is here. Is here. Okay? And it is 7.5. Okay? Do you see it? And here is 4.5. Here is a 4.5. That is only one standard deviation away. Do you see that? Now this guy, now if it's a 2 standard deviation away, then what's that? If it's a 2, what's the value value here? 0.3. 0.3 plus this. 0.9. Okay? For person B. Here, if it is a 2, if it is a 2, 0.3, okay? Okay? Now, his performance, 0.4, is the landing between the two, the value, the negative 2, the negative 2 and the positive 2, this score. For person B, from 0.3 to 0.9, total is what? 95%. Okay? 68, 95, 99.7 rule. Okay? Now we need to calculate what's the probability that this happens. If the probability is large, like more than 5%, then we should trust him, say he's innocent. That's true. He is 60%. Just this morning, just random, due to some randomness, not doing as good as 60%. So what's the probability that to find the z score? 0.4 minus 0.6 divided by the how many standard deviation? So for person A, that is 2. That is a negative 2, right? -1, -2. For person A, so I didn't do this because by looking at it, -1 -2, right? This one minus this one divided by 0.1. Divided by 0.1, that is -2. But for person B, we have to do a little bit of math here. So it's a negative, it's not too bad. Negative 0.2 divided 0.15. And the z score is negative 1.33. Negative 1.33. I will follow here. So the question becomes like this. I just rephrase it. This is the middle one. And when this is a z-score, the z-score here is negative 1.33. What's the probability? What's the probability here? What's the probability here? What's the probability being here? We need to look at the z table. if this is a minus 1, if this is a minus 1, do we need to look at the z table? If this is a minus 1, so this is positive 1. Do we need to look at the z table? Because how much according to our rule? Because how much according to our rule? 68%. Okay. When is one standard deviation, when there's one unit of a standard deviation, plus minus 1 unit standard deviation, this is a 68%. Half 34%. Okay? This is a 34%. This part plus this part, solid red plus solid white, is a 50%. So this is a 16%. It's a 16%. Okay. But because this is not in camera, so I need to. But right now we are not. We are in negative 1.33. We are in a negative 1.33. Then similar question. What's the probability? What's the probability here? What's the probability here? Then, because this is not a clear cut like 1, 2, 3, is some kind of fraction. We need to look at the z table. We need to look at the z table. Unfortunately, this is not printed in the book. It's mentioned. So for 1.33, we just when checking the table, we just use a positive one, because for negative we can convert 1.3 and 3. Do you see that? 1.3 here, okay, and find the 0.01, 0.3, so is 4082. 482. That is I need to bring this inside the camera. That means if it's positive 1.33, according to this table, the area. So this is 0.40 It's a 0.4082. And it's enough for our class. We just ignore it. Okay? 0.4. This is a 0.4. Okay? And what's here? What's here? What's this area? What's this area? It's the same. This and this is the same. Symmetric. Okay? So it's a 0.4. Okay? And what's here? What's here? Right. 0.1. 0.1 plus 0.4, that's a 0.5. This half is a 0.5. Okay? So for the negative 1.33, this is a 0.1. It's a 0.1. These days, people do not use the table anymore. They type in the computer. I will show you. I'm not responsible for teaching you how to use a computer to calculate these areas. But I will show you, just to give you a sense what it is by using Python. Okay, so the bottom line is the person B. Person B, his z-score is minus 1.33. His landing 0.4. However, his standard deviation is different, is wider. So he is closer to the 0.6. He is only 1.33 unit away. He is only 1.33 unit away. For the person A, he is 2 unit. Even his performance is 0.4. But his z-score is a 2. He is 2 units away from what he claimed. From his claim. So for person B, that which color? So he's landing here, but all these what's here according to our calculation. According to our calculation, is 0.1. Is 10%. Is 10%. Are you following? Well, we get to the end now. So there's a 10% chance that his true performance is 68%. That 10% chance, even though it's small, but we still intend to trust people are honest. Even though it's only 10% chance, only 10% chance that he truly exists. But one of the 10 days, only one of the 10 days, he's doing bad. One of the 10 days he's doing bad. is a 10% chance. So when p is greater than 5, we trust, so this is true. Okay, yes, well, maybe today is too cold. 10% chance. So, yeah, okay, we trust that his claim is right. We trust his claim. A little bit mind twisting. Okay, we take a break now. Okay.